Hi, hi, it's Doug. Check out this roller coaster ride for a second. This guy's having a lot of fun. Now, one of the things that makes roller coasters so fun are all these ups and downs. When roller coaster designers create rides, they have to figure out how high to make the hills. So let's look at a few roller coaster designs to see how high the hills are. This is the layout of a roller coaster called the Intimidator. The cars start out in this building and they go up this big hill. They roll down, they swing to the right, turn back around, then they make their way up another hill, and so on. The cars, you can see, they go through a bunch more twists and turns on this ride. There's a few low hills, which you can see pointed out here. Out of all the hills in the ride, though, the very first hill is definitely the highest. Alright, let's look at another roller coaster layout. This one's called the Behemoth. Its cars start in this building. They immediately swing to the left, climb up this giant hill, roll downhill really fast, and then go up another pretty tall hill, and so on. Now you see there are lots of hills in this ride. If I point them out, whoa, there's a lot. Most of them are pretty high too. But the highest of them all was this first hill that the roller coaster goes up. So in both of the layouts we looked at, the first hill was the highest. That's not a coincidence. You could look at 1,000 more roller coaster designs, and their highest point will always be their first hill. Why do you think that is? Why is the first hill in a roller coaster always the highest? Here at Mystery Science Labs, I'm setting up a model roller coaster to figure out, why is the first hill always the highest? Now, right now, I've only built one hill, the first high hill. So I still need to make the second hill. I'm going to make this hill lower than the first one, just like a real roller coaster. Alright, so let's see what happens when I drop a marble off the first hill. Ooh, makes it. Now, it made it over that hill. That's not surprising, we knew that would happen, right? But what if the second hill is higher than the first hill? Like this. Now, what will happen when I let go? I'm going to give you 10 seconds to turn to your nearest classmate and predict what you think is going to happen when I let go of the marble. Okay, let's see. Oh, it doesn't make it over, does it? So why does the marble make it over the lower hill, but not the higher hill? So why didn't the marble make it over the higher hill? Why does the first hill have to be the highest on a roller coaster? You all had a chance to discuss, and hopefully you're thinking about it in terms of energy. When the marble is dropped from a certain height, like say from here, there's a certain amount of energy you've stored in it by placing it up this high. The higher it's dropped from, the more energy you store in it. But that's all the energy it gets, no more. Watch, by the time the marble reaches the bottom of the first hill, it's got all the energy it was going to get from being dropped. You know, it's kind of like the marble has an energy meter, and at this point it's fully charged. In order to climb the second hill, the marble is going to use that energy, like this. See, it's going up, and it's losing energy. Since the second hill is taller than the first, the marble doesn't have enough energy to get to the top. You can see here that this marble was only able to get halfway up there. In fact, it can't roll up higher than the height of the first hill. You can actually see the same thing on the swings at the playground. If you pull back the swing like this and then you drop it, see, the swing isn't going to swing back any higher than where it started from. Let me show you that again. The swing is going to be dropped from here at the green line. When this boy's swing comes back, he's not going to go any higher than that line. Watch. Did you see that? Now, instead of a swing hanging from a beam like you see here, imagine we had a bowling ball. And imagine if you took your hands and you pulled back the bowling ball so that it was ready to swing. But now you put it against your forehead, like this kid is doing here. So you see that? He's got a bowling ball on a string, pulled back and ready to swing. What's going to happen when this guy lets go of the bowling ball? Is it going to swing back and hit his face? Well, let's find out. You ready?
I had nothing to do with this. Okay, Brad, go ahead. Keep your head back.
No, it didn't hit him. He looks a little worried, but he doesn't need to be worried. It actually can't hit him. The bowling ball can't swing higher than the height it was dropped from. So what is the motion of the roller coaster, a swing, and a bowling ball on a chain all have in common? They all get their energy from starting up high. They're getting their energy from height. And that energy isn't enough to take them any higher than where they started from. Now, I should note, the bowling ball or the swing could have gone higher. And so you do have to be careful with this, because if someone pushes on you rather than just lets you go, watch what happens. See, this dad is pushing on his son each time the swing comes back. And so this little guy is getting extra energy from his dad's pushes, making him actually go higher and higher with every swing. So to sum things up, a roller coaster gets all its energy from that first big hill. The energy stored from going up that big hill is what gets the roller coaster all the way to the end of the ride. If you made the second hill the biggest hill, the roller coaster wouldn't make it over. That's why the first hill in a roller coaster is always the highest.